So in today's lesson, we're going to be talking about the images formed in concave mirrors. So we've looked at plane mirrors, those flat mirrors. Now we're going to be looking at curved mirrors. And so I want you to think back to perhaps your childhood about what your idea of what a concave mirror is. So hopefully what you're thinking about is that a concave mirror is the type of mirror whose reflecting surface curves inward. Okay, so sort of like if we were to draw this, and this inside part here is the reflective surface. Sometimes this is called a converging mirror, and the reason for that is that you can see that all of the incident light rays, those light rays that are aiming towards the mirror, all reflect back to a single point called the focus or the focal point. And so converge just means come together. So a concave mirror is the type of mirror that causes those light rays to converge at a single point. Okay. Now, the optic symbol, which is the symbol we're going to be using in our lessons today, looks like this. Now, it looks a lot like our image for our symbol for the plane mirror, and I can tell in this case that the reflective surface is on this side to the left because of these little sort of hatch marks, these dashes that are on the opposite side, which shows that this area right here is behind the mirror. So in the previous lesson, we looked at how these incident light rays behave when they strike a plane mirror, right? And how we can locate the image based on how those light rays come together. We're going to do the same thing with the concave mirror in this lesson and see how those incident rays behave and how different incident rays can come together to form an image point. And so before we get into the lesson today, there's some important terminology that we have to understand so that we can have some reference points as we discuss these diagrams. So first of all, I'm going to talk about the mirror itself. Okay, and so this would be in front of the mirror and this would be behind the mirror. Okay, we can tell based on those hatch marks here. So I want you to think back to grade 10 math when we talked about parabolas, right? We can see that this concave mirror sort of forms a parabolic type surface in a sense. And so you'll remember that if we look at the lowest point or the highest point on a parabola, we call that the vertex. Well, that may help you to remember where we're talking about the point we call the vertex on a light ray diagram of these curved mirrors. Okay, so that is the vertex. Okay, now you'll notice here that we've drawn a line towards the vertex that meets the center of that vertex, that meets the vertex at a right angle. Okay, so in other words, it is normal to that point on the curved mirror. That is what we call the principal axis. Okay, and so we're going to be placing objects along that principal axis and moving them forward and backwards, and seeing where the image would be located based on how the light rays are going to reflect. Okay, now the center of curvature. So the center of curvature is basically, I want you to envision, and this is a little bit tricky here to envision, but I want you to imagine that this mirror was a circle, and then that circle went all the way around. Now the mirror is not drawn really super effectively to show you that, but I want you to imagine that this center of curvature would be the center of the circle. Right? So if we extended that mirror, then this right here would be the center of the circle, and the distance from C to the vertex would essentially be the radius of that circle. Okay, so that's some important terminology. What I'm going to do is I'm just going to, in case you're interested in writing some of these details out, what I'm going to do is stop the screencast and move up to those definitions and hold them for a bit, and you can pause the video to write any of them down. I'm going to talk a little bit about them as well. So here we can see in this diagram a little bit better that the center of curvature, here would be the center of curvature for this mirror. This is a concave mirror on this side because I can see that behind the mirror is over here based on where the hatch marks are located, right? So this here would be the center of that circle. So if I were to draw a line from the center outward, that radius, that could form the principal axis if it happened to hit at the middle of this mirror. Okay, now convex mirrors we're going to talk about in the next section. So the principal axis and the vertex we've spoken about. Here are a couple of points. If you want to have them in your notes, you can certainly write them out. The focus we haven't talked about. So the focus is that point where the light rays will converge. Okay, they will converge at that singular point called the focus. Okay, and we symbolize it by using a capital F. Okay, now I also should point out we often will write the center of curvature as capital C and the vertex is simply as V. Okay, and so what is the focus? Well, the focus is essentially exactly that. It's the point where any incident rays that reflect back, they will reflect back possibly towards the focus, right? And those we're talking about parallel incident rays. Okay, so parallel rays that are incident and parallel to this principal axis will strike the mirror and end up going back through that focus. So this is your little introduction towards how to draw light ray diagrams. You're going to be going through an exercise with concave mirrors to help you locate the images in concave mirrors. It's interactive and you'll be looking at a simulation, so hopefully that will help you to make sense of it. As always, pop into our Zoom meeting at any time in order to clarify any questions or ask for some more information. I'll be happy to help.